This is the demonstration of the ultra-low-cost global health simulator, the general functionality of what it will eventually be.
So we have a mannequin here that we're going to put our fake tissue on. This is a fake tissue made of bioplastics. So we put it right here where the C-section would be. We have 4 probes on the plastic connected to the Arduino board. And then the Arduino is connected to the computer, which is then going to plot wherever the tool is going to be. So there's a scalpel, place it in the middle, you get a result, and then as we move it, you can see that the tool is tracked in the computer.
So for the 2 different methods that we're using, we're utilizing either try to figure out the resistances by interpolating and doing voltage dividers, or method 2, we're measuring a strict voltage. This method has proven to be a little more challenging and less consistent, so we have moved to method 2 as our primary goal to achieve, where that we have the resistance built in with the material that we're using. We've got voltage supply switching from the sides to the top. This corner is always grounded, and then the probe that you're using, that would be the scalpel or whatever, is the voltage meter, and that connects directly to the Arduino and would be measuring a voltage. So we've got a chronological order of our different types of samples. So this is a sample that we made a mere half-hour ago, and as you can tell, it's already pretty dry, and it's very malleable and ductile. It's good. It very represents skin a lot. However, what we noticed is after a couple days, maybe a week, it gets to be much more plastic-like, and it's not quite as ductile, and it's not as good to represent skin. So that's why we kind of moved forward
with a different recipe that's called Robotics, which also has vinegar and starch in it. So it still contains glycerin, water, and gelatin, but we add vinegar and starch. And this is actually after drying for a long time. We made this a couple months ago, and it's still really flexible and yet strong. So we got much better results in terms of skin and in the long run with this. The problem is that it takes a while to dry, probably a couple days to a week, and then we have bubble issues, which is inconvenience for homogeneous plastic for the resistance. So we did figure out a way to prevent bubbles, which is only it depends on the way we heat it. So if we heat it for a little shorter time, we actually get way less bubbles.
And then these are 2 more usable samples that we, using the same recipe. However, this one is there's carbon powder in it, or graphite, to increase the conductivity, or that was our original thought. However, they're both the exact same original material with the added graphite to make it black, but they both have pennies on each corner, which helps to increase, or what we think, to increase the voltage that is supplied to the sample. And these both have worked out very well, and we are working to further finalize and perfect these models so that they are completely homogeneous as well as conductive enough to make the voltage measurements.